Welcome to another interesting video related to free body diagram for a block on an inclined frictionless surface. So when a block is released at rest on an inclined frictionless surface, I'm going to show all action-reaction pairs of forces which are applicable in this scenario, essentially the forces due to gravitation and the normal forces. I'm going to draw the free body diagram for the block, and then I'm going to write the equations for equilibrium along the y and the x-axis. So y-axis will be normal to the inclined surface and x-axis will be along the inclined surface. And using the equations for equilibrium, I'm going to derive the acceleration of the block. Talking in general, I'm going to explain in cases of problems related to inclined planes why we should consider y-axis along the normal to the inclined surface and therefore x-axis parallel to the inclined surface. Let's start. So coming to the first part, all the action-reaction pairs of forces which are applicable to the system. And the system is we have a block of mass m which is on an inclined plane, and the inclined plane makes an angle theta with respect to ground. So the system is the block and the earth. So let's see what are all the gravitational forces that are applicable. So I've drawn the forces over here. The first will be the force by earth on the block, and that is the weight of the block, and that is equal to mg. And that's a force acting on the center of mass of the block. I've indicated with a dot like this, and it is directed vertically down, actually pointing towards the center of the earth. So it is normal to the earth. Yeah. So that is one force. And the reaction counterpart of this force will be the force in the opposite direction. That is force by block on Earth, which is equal in magnitude but opposite in direction. And since it is a force acting on Earth, so therefore I've indicated again with the dot sign. Now, with respect to the forces, so one thing that you must have already observed is that FEB, as far as the vectors are concerned, will be negative of FBE. So as I said, these two forces are equal and opposite. But as far as the magnitude is concerned, we still have this equality. The magnitude of the two forces are the same. All right. So if I ask you, out of the two forces, which one is to be considered for the free body diagram for the block? Out of the two, the only force relevant will be this one. So if I have to draw it on this, if assuming this point is the center of mass of the block, and I have to draw the force of gravitation, which is acting on the block. So this will be that force, and that will be equal to the weight of the object given by mg. Let's now focus on the other pair of forces, which is the normal forces. So we know that the block is on a inclined surface, and since we have two objects in contact, and both the objects are exerting force on each other, so we will have a pair of normal forces. So the first force to be considered will be normal force by earth or ground on the block that will be exerted by earth normally in perpendicular direction, and it will be exerted on the block. And the other dotted force which I have drawn will be normal force by the block on the ground or earth, and that will be acting in the opposite direction. With respect to the forces, the two forces will be equal in magnitude and opposite in direction. So we have this negative sign over here. And in terms of the magnitude of the two forces are equal in magnitude. Now, out of the two, which one is applicable for the free body diagram for the block? It has to be the one which is acting on the block. So which means this one. So if I draw, it will be acting on the center of mass of the block. I can draw a normal force over here. I'll be giving a more organized diagram a bit later, but right now it is important to understand that the normal force will be looking something like this. Okay. Later on, I'm going to combine the normal and the gravitational forces in one picture. So just hold on. So the two forces that we have seen, one is the normal force acting normal to the surface, and other is the weight of the block, which is equal to mg. If we have to find a resultant force acting on the block, so we have to make sure that we choose x and y axis which are suitable for our calculation. So we know that the movement of the block will be along the inclined plane. Okay, so let's take that direction as the x direction or x-axis. So I write this x over here, and therefore the normal to the x, I will consider this as the y-axis. Now the challenge here is that while the normal force is acting in the y direction, the weight of the block is not acting along any of the two directions. So it is acting vertically down. Therefore, it is required that we resolve the weight into two mutually perpendicular components. And let's see how we can do that. So it is given that the angle of inclination or angle of incline is theta. So in this triangle, this is perpendicular. So this will be 90 degree. And therefore, sum of three angles of a triangle is 180 degree. So therefore, this will be 90 minus theta. Since this is 90 minus theta, so this will also be 90 minus theta because these are corresponding angles in case of parallel lines. And we know that maybe I can make some letters A, B, and C. Since we know that angle ABC is 90 degree, therefore this angle has to be theta. So now it is very easy to split the weight into two components. So the component which is along the angle theta will be mg cos theta, and also the component which is perpendicular will be mg sin theta. So this component will be mg sin theta. So to summarize, now we have three forces which are in our required x and y directions. So we have the mg sin theta, which is the component along the inclined surface due to the weight of the object. And then we have a component of the weight which is acting normal to the surface, and that component is mg cos theta. And the third force is we have the normal, which is acting normal to the surface. So let's see how we analyze them in the next step. So here is the free body diagram for the block. Important to mention here that it is given that the force of friction is 0, and therefore no forces related to friction have been drawn. I'm going to cover the inclined surfaces with friction applicable in some later videos, but right now, for simplicity, I deliberately captured the scenario that there is no component of force of friction, and therefore it is easy to understand this scenario. So coming to the next part, write the equilibrium equations. So now that we have all the forces identified, basically three of them, we have to apply the equilibrium condition onto the y-axis and also onto the x-axis. So you remember the y-axis that we have chosen is normal to the surface. So this is the y-axis, and the x-axis is along the inclined surface. So x-axis is on this side, and it is always good to consider positive x direction along the direction of the motion of the object. So we know in that case that there is a force mg sine theta which is going to bring the object down along the inclined plane, and therefore the motion will be downwards along the inclined plane, and we will consider that as a plus x direction. All right, so let's apply the first along the y-axis. So the equilibrium condition, Newton's second law, says that the net force along the y direction has to be 0, which means vector sum of all the forces along the y direction should add up to 0. So in our case, we have two forces, Fn and mg cos theta. This condition of vectors is possible only when magnitude Fn is equal to mg cos theta. So that's a very important condition. Since the object is going to remain at the surface, it is not going to be in a motion normally up or normally down. Therefore, the two forces have to be equal in magnitude. Okay. And coming to the x direction, equilibrium, my bad, I typed it wrongly. So this should be equilibrium parallel to the inclined surface. So once again, so our x direction is referring to the equilibrium in a direction which is parallel to the inclined surface. Yeah. So again, the condition is the same as per Newton's second law. The net force along the x direction, which means vector sum of all the forces, should be equal to mass of the object m times the acceleration. Since we have only one force which is acting downward direction along the inclined surface, and there is no other force, therefore this block is expected to move down, slide down. Yeah. And when it is sliding, it will slide with certain acceleration. And that acceleration we are calling it as a. So therefore, mg sine theta will be equal to m times a. M and m cancel on both the sides. Therefore, a equals to g sine theta. So let's analyze the forces and also the acceleration for the different cases of theta. So let's say when we have theta equal to 0 degree, angle of inclination is 0. That means it is a horizontal surface. Yeah. So the normal component of the weight will be mg cos theta. So it will be mg cos 0, and cos 0 is 1. So therefore, mg will be equal to Fn, the normal force. How about mg sine theta? The component along the inclined surface or the horizontal component. This will be mg sine 0, which is 0. So this will be 0. And how about the acceleration therefore? The acceleration will be equal to g sine theta. That will be 0. So which is a observation matching with the case that the block was on a horizontal surface. There will be only two forces acting in this case. One is the weight of the object acting vertically down, weight given by mg, and the normal force by the ground on the object, which is n, which will also be in magnitude equal to mg. And there will be no motion of the object along x or y direction. So in this case, we eventually our x-axis translates in this direction and y-axis translates along this direction. Now let's take another case. Let's say where we have theta equals to 30 degree angle of inclination. So the normal component of the weight will be mg. That will be mg cos 30. So that will be equal to mg root 3 over 2. And that will also be the Fn, the normal force. Okay. And the component along the inclined surface will be mg sine theta, which is mg sine 30, and which will be equal to mg by 2. And the acceleration in this case will be equal to g sine theta, which is g over 2. So in this case, this is a very small angle, 30 degree, and the normal component of the weight will be in this direction, and the component of the weight along the inclined surface will be in this direction, and the normal will be acting along this direction. Okay. Now let's take one more example. Let's make theta equal to 90 degree. So in this case, mg cos theta will be mg cos 90. So cos 90 is 0. So that means this will be 0, and therefore there will also be no normal component. Yeah, there will be no normal force acting on the block. And mg sine theta will be mg sine 90, which is mg. And acceleration will be equal to g sine 90, which will be equal to g. Are you able to relate this case? How pictorially this will look like? So it will look something like this, that we can represent object 2, which is our ground, like this, and we have the block which is in contact, and the block is sliding down. Okay, this is as good as to say that the block is only under the influence of force of gravitation. Okay, so the only force which is acting in the y direction will be the mg, equal to the weight of the object. And since there is no component of the weight along this direction, therefore there will also be no Fn. Fn equals to 0. Yeah. So it is as good as this object was released. We don't even need object 2. So in terms of the, I can treat this as object 2 and this as object 1. So our case reduces to the scenario where even if object 2 is missing, then the block will fall only under the influence of gravity. Okay, so the two scenarios are identical. So the scenario is like free fall under the influence of gravity. Also, a general observation with reference to A equals to G sine theta is that since theta will always be practically less than 90 degree, which means theta will be in the first quadrant, and we know that sine theta will therefore be always less than 1, which means that the acceleration, which is given by g sine theta, with sine theta being a value less than 1, it will always be less than g. Okay, so on an inclined surface, object will always fall with a value of acceleration which is going to be less than. Now let's spend some time on the x and y axis to be used for the inclined surface problems. So always remember as a rule that for an inclined surface, the y direction or the y axis should be normal to the inclined surface, and the x direction should be along the inclined surface, parallel to the inclined surface. Doesn't matter, you can take this as plus if the object is sliding down along the inclined plane, or you can take this as plus if the object is sliding up along the inclined plane. So similarly, it's just a change of the direction of the block. So sliding down along the inclined plane could be positive x if the object is coming down, or if the object is going up along the inclined plane, then this should be the positive direction of x, and this can be the negative direction of x. Why do we do that? What's the logic behind this? Because if you see the motion of the object is going to be either move upwards along the inclined plane, or move downwards along the inclined plane, or stay at rest along the plane. So everything is happening on or along the plane only. So therefore, it makes sense to consider x-axis along the inclined plane. And the object will never have a horizontal motion. What I mean by horizontal motion is that there is never a scenario possible that you have object moving like this. That is simply not possible. Object will not move left or right. That means it will not move horizontally left or right. And also, object will not move in this vertical direction up or vertical down. So this is ruled out. How it is possible? Object will move only either along the inclined surface up or along the inclined surface down. Okay. What is not possible is that object will never cut into the inclined plane. Okay. Therefore, practically it does not make any sense. So therefore, this scenario is ruled out, which I've also shown over here. It will never happen that you will take x-axis along the horizontal and you will take y-axis perpendicular to the horizontal. No, you will always take this scenario or this scenario. Also, some more insight into this. If you see of all the forces that are going to be available to you in such problems, what is going to be the direction of the forces? So you are given a applied external force, FEXT. So that may act. So let's say you have a object on the inclined plane. One possibility is that you may be given a scenario wherein a string is tied and then there is another weight over here, in which case we are having an external force acting in such a way that it is going up the inclined plane. Okay? Or the external force may be applied in such a way that it is trying to pull the block down the inclined plane. So these are the only two ways in which the external forces can be applied. So push or pull along the inclined plane. All right. Now coming to Fn, the normal force will always be acting perpendicular to the inclined plane. That's the reason we go for this as the y direction or y-axis. And for the external force, it makes sense to consider x along the inclined plane. Then the third force will be the force of friction. So we know that the force of friction is acting always along the surface of the inclined plane. Therefore, it makes sense to consider our x direction as along the plane. Now, the only force which is not aligned with the required x and y directions is the weight of the object. Why? Because we know that the weight is going to act vertically downwards. So we can easily handle this force. We can manage this force. How? By resolving the weight into the components. And we know that we can take one component along the inclined plane and one component perpendicular to the inclined plane. Yeah. So all the forces that come into the picture in case of a inclined surface, all of them, all the forces related to the motion of the object along the inclined plane can be managed if we take x and y direction as shown in this picture. All right. So here I mentioned that all the forces are already aligned with the required x and y direction except the weight, which we can resolve easily. And when the motion is bound to happen along the inclined plane, it makes absolute sense to consider the x direction along the inclined surface and the y direction perpendicular to the inclined surface. I have added one comment that take plus x as the direction where the motion of the object is. So if the block is sliding up, then up the inclined plane should be considered as positive x. And if the block is sliding down the inclined plane, then consider the down along the incline as the positive x direction. So these are some simple tips and tricks which are going to be very useful to you when you solve the problems or numericals. Thank you for watching. Please don't forget to like, subscribe, share, and drop your comments. They definitely help us. Thank you.